All right, so welcome back. This is Chapter 8 Lab Demo. All right, so let's hope that we'll make a little bit sense of what we just did. The best way to do that is to bring a case scenario. In the case scenario I showed for you over here, you are the network administrator. You inherited, or you were given, this network ID of 204.17.5.0/24, tells us a class C, and you're asked out of this network ID to create 5 new network, and each network should support at least 28 hosts, meaning 28 computers. Well, to solve this problem, question number 1 that you need to ask yourself, how many bits I need to borrow from here, right, from the host, in order to have 5 network, and each network will have 28 hosts? Well, the number is 3-bit, because 3 bits to the power of 3, it's 2 times 2 times 2, which is 8, which is more than 5 network that we want. As of the host, all right, so 3 bits will go into the host, and we'll take away 3 bits, and we're going to leave 5 bits for the host, for the host in this new network that we are creating. Well, we're going to leave how many bits for the host? We're going to leave 5 bits to the power of 5. Well, needless to tell you, to the power of 5 will give you a lot more than 28. But for now, all right, so now we have 3 for the what do you call the new network subnet mask, and we have 5 bits for each host. Now let's find the magic number that will make life easy. If you remember from my lecture, I said the magic number is the last man standing. And the last man standing in all this here standing is this one here. There is a blue. And this blue is, if you want to find its value, the first value is, you remember, is 128. The second is 64. And the third one is 32. So our magic number will be 32. What does it mean? This means that our network, all the network we're going to create, all the 5 network we're going to create, will be incremental of 32. It means your first network is always 0. Your second network is 32. The third number, we have 0, we have 32, 64, I believe 96, 96, 128, 160, 192, and 224. All these are new possible networks. Okay. Number 4. Find the network using this is to the power of 3, and what do you call it? To the power of 3 for the networks, and to the power of 5 minus 2 for the host IDs. Right? To the power of 3 for the network, all the possible networks, and to the power of 5 minus 2 for all the hosts inside each network. If we do the math, what are we going to find out? We're going to find out that 2 to the power of to the power of 3 of for networks, using the magic number like I just said, we're going to have this network 0 all the way down to network 7, starting by, like I said, 0 is always the first one. 32, 64, 96. Watch how we are going into an incremental number of 32 the magic number gave us. So as a result, the network will be, our network will be, network 0 is 204.17.5.0, and the last network, which is the 8th network, it's 204.17.5.24. Now, the new custom subnet mask, it's no more 255.255.255. It's now 255.255.255.224. You may ask yourself, where did we get this 24? Okay, remember that in custom subnet mask, all the bits are always on or always 1. So how many bits we borrow? We borrow 3 bits. If you turn all those 3 bits on, you're going to get 128 plus 64 plus 32, which is 224. We got 255 here because we have all 7 bit on. We have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 255. But here we only have 3 bits. Those bits are 128 plus 64 plus 32. So our new custom subnet mask that all the network would have is 224. Now let's find all the possible hosts Well, let's find the 28 hosts, or all the possible hosts per each network. Let's try it for network 0. Now, what did we say about the 0 host? We said in the host, we do 2 to the power of n minus 2. It means when you find your host, always exclude the first number and the last number, which is the first number is 0, which is this network, and the last number, which is 32, which is the last number, which is, I'm sorry, the last number is 31, which means all ones. So as a result, if we exclude the 0 and we exclude the 31, the only possible number we have 1 to 30. So in the first network, this network will have 1 to 30. The second network will have 33 to 62. The third network will have 65 to 294. I want to show you something. Watch how the range of the network, right? Watch how the range of the network, you stop before you reach the next network. So you go from 1 to really 1 from 1 to 32. But we said you can't use 32 because 32 is all 1. You can only use the number less than 32. Now after 32 comes the next network, which is 33. Right? It comes 33. And that's how we'll find all your, what you call, all the possible hosts per each network. Before I move on to the next one, I repeat again. We found all the possible network, all the possible 8 networks, they're right here, from 0 to 7. They all are they're all 24. The new subnet mask, they all have 255, that 255, that 224. And they all have, and they all are going in an incremental number of what do you call it, of 64. So watch, we have 0 here, 32, 64, 96, and 128. And per each network, we calculated the possible what do you call it, host. This is the network ID, and this is the host. Now we need to move into applying the solution. Now we have all the network. We know all the network. We know the custom subnet mask. And we have the 5 now. We're going to use 1, 2, 3, 4, and 5 if you want. And we have the range of each, the range for the host per each network. Let's apply our solution. That's what we're going to, let's apply our solution. How we do that? Well, you can see over here, this is all our network. This is, what are we going to start? 32. This is our first network, 204.17.532. What is the first valid IP in our network? It was 33. It was 33 right here. All right. Right here, this is our second network, 64. And what is the first valid host IP in this network? It was 65 over here. All right. So let's go down here. Here's another network. Here's a third network. Third network is 204.17.596/27, which is 224. Now, and what is the first valid host in the 96? It is 97. And then we did the same thing here, right? Here, right? We did the same thing here. We did the same thing here, 204, 128. The first valid number is 129. We did the same thing here. The first valid host in 204.17.5.192 is 193, right? And the same thing here too. So how many network we use? We use 1, 2, 3, 4, 5, 6, 7. All right, so we used 7 IP addresses, 7 network, 7 new custom subnet masks, and we have host IP addresses for each network. At this time, what I need to do is move on, bring all the, go to Packet Tracer, design this network, and start applying IP addresses using the using this IPs that we have here per each interface. So in the Packet Tracer, what I'm going to do, and I'm going to bring router 1 and I'm bring router 2. I will connect them using serial number and watch how each, what do you call it? So I'm going to make this one here is a serial interface over here, and here this router is going to have how many NIC cards? It's going to have 1, 2, 3, 4. 4 NIC cards. Where 3 NIC cards, if you want, I'm going to make this 3 NIC cards, just a matter of choice. 3 NIC cards are gigabit NIC cards, right? 1, 2, 3. And this one here, I'm going to make it serial interfaces here, or I can make all of them serial interfaces. Now remember that routers by default do not have 4 network interfaces. You need to turn off the router and add them one at a time. Add all those. So you're going to turn off router 1, add all serial interfaces, 4 serial interfaces, then turn the router back on, then go back to router 2, turn it off, add 4 serial interfaces, then turn the router back on. Then you go into, you're going to do enable config t int serial 00 and give the first, what you call each serial 00 IP address 192.168. I'm sorry, not 192. 204.17.565. I'm sorry, 565 for this interface, and you put space 255.255.255.224, and you move to the next interface, int s001, and the same. You give it the same IP addresses, and with this you have you just discovered all the IP addresses, all the network for the new subnet mask is needed. You find a new custom subnet mask, which is /24. You find how many bits you need to borrow, and you find all the possible hosts per each network, and you assign those hosts to each interface per the 2 routers that you have. All right, that's all done. And I want to repeat, I understand that this concept is a little difficult, a little challenge, and I understand it will take a little time, and I hope with going over this, I made it a little bit easy for you, and I highly advise you to go to YouTube and look for dancourses.com in case you need more information, in case you need to hear this from another point of view. Dan is a friend of mine, and he's a great teacher, and he has years teaching this, and I'm sure you'll learn a great deal from Dan if you want another perspective and looking at this from another perspective.